Good morning, guys. Just prepping you. This video may be a little bit longer just because I want to make sure we have plenty of examples for you to refer to. So let's get going pretty quickly here. Okay, so what we're doing is solving literal equations, okay? And that is equations with multiple variables. It means more than one letter. More than one letter. All right, so let's look at these two examples. Okay, so we're solving for x. So we use the same solving equation rules, okay? So my goal is to get the x by itself, so I have to move what's farthest away. So I'm going to add 5 to both sides. So we have 2x equals 18. And now to get the x by itself, we divide by 2. This is what we've been doing and drilled into the brain. So we end up with x equals 9. The difference here is we're going to do it the same processes, but we're going to have all letters. So I've got to move what's farthest away, which is the b. So I'm going to move the b to the other side first because my goal is to still get the x by itself. I subtracted 5, so I'm going to do the same. I am subtracting 5 right now, so therefore I'm going to add 5 here. So I'm going to do the same thing. I'm going to add b to both sides. And this zeroes out, and I bring down the rest, and I have ax equals, this is where things are going to get different. C and B are not like terms. I cannot add them together. So I'm going to actually just write C plus B. Now I continue my work. My goal is still to get the x by itself. So at this point, I'm going to do ask how are they connected? They're multiplying, so I'm going to divide by a to everything. This cancels, and therefore x equals c plus b, all divided by a. This is my final answer. So we're going to look at the similarities and differences between the two equations. Some things to note. Both use opposite operations to isolate variable or what you want. The difference, the literal equation doesn't simplify nicely. It doesn't simplify to some nice number. Simplify nicely due to multiple variables. These are the similarities and the differences. Similarities and differences between the two. All right, now we're going to just work through some examples because there's lots of different ways to do this. All right, number 1. Remember, we're solving for W. It tells me what I'm solving for. I ask myself, what's happening to the W? It is being multiplied by the L, so I'm going to divide by L on both sides to get that W by itself. So I'm now going to say that A over L equals W. That is my answer. With this, there's not a way to check. That's the kicker with these. Okay. Number 4. I'm solving for T. Well, I can move one thing at a time, or I can realize that I'm not going to circle that because it takes 8. I'm just going to underline it. Okay. I can look to see what is with it. The P and the R, they're both multiplied to it. Since it's all multiplication, there's not anything else that's going on, I can divide by both at that same time. And now we end up with T equals I over PR as the final answer. Next example. R. I want just R, not R squared, just R. Remember that. Okay, so I'm going to look to see. I've got to move what's with it first. I can't take the squared yet. I've got to move the pi. Pi is being multiplied, so I'm going to divide by pi to both sides. And that's going to give me A over pi equals R squared. I am not finished yet. R is not by itself. This is where we have to remember, how do I get something, how do I undo squared? The opposite of squared is square root. So if you need to remember that over here, okay, x squared is opposite of square root of x. Those are opposites, which means I can take the square root of each side. And when I do that, that's when the R gets by itself. So I'm going to have R equals the square root of A over pi. And this is my answer. All right, moving right along. This is a simple one. Just wanted to make sure we could do this. We're solving for C. How is it connected? I'm subtracting S, so I'm going to add S to both sides. This cancels, and I end up with C equals M plus S. And there's my answer. I'm looking for M. What is connected to the M, or how is M connected to the V? It's dividing. How do I undo division? We multiply. So I'm going to multiply by V to both sides, which means I end up with M equals dV. Next page. Key to think, some little quick notes here. You want to do PEMDAS backwards when you're thinking about this. You want to remove fractions by multiplying by the reciprocal. You want to always remove the fractions. If you can remove them first, get rid of them. Okay, remove fractions first. And then the last step is usually to divide by whatever is next to your variable. That's most of the time what happens. All right, so here we go. We're going to jump down and we're going to look at number 11. We're solving for M. Well, first things first, I got to get rid of that fraction. It's dividing by 2, so I'm going to multiply by 2 on both sides. When I multiply by the 2 on the right, this cancels. So now I have 2k equals mv squared. It's not by itself yet. So what is connected to the m? The v squared by multiplication. So I'm going to divide by v squared on both sides. And when I do that, we end up with, this cancels, and I'm left with m equals 2k over v squared. This is my final answer. All right. Jumping down to 14. This is an extremely common equation that you will use to solve. This is standard form. We will learn how to do this and with this in the next several chapters. All right, so we are solving for y, which is very common. You're changing it to slope-intercept form, y equals mx plus b. So I've got to move what's farthest away first. So I need to move the AX over here. How is it connected? Okay, I need to make this zero out because it's added to the BY. So I'm going to subtract AX from both sides. This zeroes out, bring it down, and I now have BY equals C minus AX. And now I've got to get Y by itself. So it's B and Y are connected by multiplication. So I'm going to divide by B to everything. This cancels, and I now have Y equals C minus AX, all divided by B. And there's my final answer. Okay, 16. I know there's several of these guys, and I appreciate your patience. I'm just trying to make sure you're exposed to all the different ways because this can trip lots of people up. Okay, I'm solving for T. Again, I've got to move what's farthest away from what I'm looking for first. So I've got to move this P over here. So I'm going to subtract P from both sides. So this zeroes out, and I have A minus P equals P R T. Now I need to, excuse me, get the T by itself. So I've got to move the PR. So I'm going to divide by PR to both sides. Now, this is where you're going to be tempted to think, well, wait a minute, these P's can cancel. There's not a P in both spots, so I have to leave it be. I cannot do anything with it. So my final answer is T equals A minus P all over PR. This is the final answer. I do not try to simplify this because it's letters. If it were numbers, we might be able to think about it differently, but it's letters, so we leave it alone. Last example. 14. We're looking for B1. That is inside these parentheses. That means I got to get rid of everything on the outside before I can even begin the inside. Okay? So move what is farthest away first. Move what's farthest away first. Well, what's farthest away, but on the same side of the equal sign, is the 1/2. Well, that's a fraction right there. I want to do the opposite of that. I want to multiply by the reciprocal. Okay, so we're going to multiply by the reciprocal. Multiply by reciprocal to get rid of fraction. So I'm going to multiply both sides by 2 over 1. 2 over 1, which means this is going to go away. Because if I do 2 over 1 times 1/2, it simplifies to 2 over 2, which is 1. So now I have 2 over 1. Well, that can be just 2. So I now have 2a equals h, open parentheses, b1 plus b2, close parentheses. And now I'm still trying to get to this B1, but I've got to move the H first. So I've got to move the H over here. It's multiplied to this. There's nothing in between here, so it's multiplied. So I'm going to divide by H. So I'm now going to have 2a over H equals B1 plus B2. Notice right now, when I divided by the H, I can get rid of the parentheses because all that's left is what's in the parentheses now. And here we go. Now I can start to get the B1 by itself. What's left with it? The B2. It's added, so I'm going to subtract B2 from both sides. This zeroes out, and now I'm left with 2a over h minus b2 equals b1. This is my final answer. Your assignment is to finish the rest of the notes problems, and we will see if we get to the classwork homework today. All right, y'all have a great day. Thank you.